This video is follow along to the presentation for the mechanical link, and it's just going to go through some of the basic utilities, tools, and sketching techniques. So we're in Autodesk Fusion, and if we expand out the data panel, we'll see the folder project, and then the folder that the files exist in, and some of the previous versions that we've worked with, and we'll see how far we get with this. So I turn the grid back on, and when we go into a sketch, we're going to pick the top plane. I probably should have done the front plane, but top plane's fine. Well, we can always finish the sketch and go back in, and what I'm checking for is the front on the cube, so that works a little better. And I'm still in inches, so let's take a moment and go over to the document settings, and in the preferences on this computer, we're going to switch over to millimeters. I could have saved it as the default there. Typically I work in inches, but for these we'll go with the millimeters. So let's go with 100 on the diameter. And if we switch over to arc, we could do these as circles. We'll go with the center point arc. We could do these as circles and line them up. We can do this with arcs. So this side, we'll go back and add it as an arc. And I haven't put any dimensions on this yet, so let's escape out of that and line. All right, and if we go back to the beginning where we started and drag, it will switch from a line to an arc. Okay, in the presentation, I did this as two circles and then connected, and we pick up the geometry. So as long as I have the tangencies and we start putting the geometry in, let's Control Z real quick, and we'll go back to the circle. And this one, don't remember if I did 50 and 100 or 75 and 100, so we'll go back into the circle, pick up the same. All right, so that grabs the geometry, and we're looking for our constraints to be tangent. And we'll go pick up the dimensions. So 250, and that did not get coincident. And one of the reasons I wanted to do the circle was to have it be able to go coincident and then go tangent. So if it still moves, it did not stay coincident. There it jumped. All right, so let's put some more dimensions, and we're going to keep working towards. So since that one's an arc, it went to a radius, and let's delete that one out. For contrast, if we go to a circle, then we'll pick up the diameter. Okay, so those look pretty good. And this is going to determine what we pick for regions. When I had the circle, then I had to pick 1, 2, 3 regions. Here I'll only have to pick the 2. All right, so we go into the extrude. We're creating a new body, distance of 50 millimeters, but we won't see that pop up until we pick our geometries. And so based on the way that we're going to build this, Let's go ahead and put in the 50 millimeters. I would like it to be symmetric and the whole length. So if I do 50 millimeters on the half length, my total will be 100. And if I do the whole length, then it will be 50. All right, so that one looks pretty good. And then we'll open up the sketch. And we're looking for coincident and coincident. And since I made that 150, then that should be 75 off of the center. All right, so at this point, I want to use the project tool to bring this geometry in. Right, and I think I missed that arc, so I still have the habit of pre-selecting. So let's go ahead and select the 3 items and then go ahead and hit OK. And those will show up in kind of that purple. So when I finish the sketch, I can go into the extrude, give it a symmetric since it's across the front plane, a whole length. This is not going to be a new body. This is going to end up being a cut. All right, so when I select that geometry, then I can go 25. And when we go to the orbit and rotate around, well, that didn't quite go the way I expected it to, because I opened the sketch on that outside plane instead of the front plane. All right, so we can move the front plane, or I could change the starting point. But let's go to our origins, and then we would be able to see the XY. All right, so that was what I was aiming for. Different ways to get to the same point. And however many times you do this, they won't ever be the same twice. So we're going to go with a right side view. Okay, maybe a left side view. And I want to do the same thing here, except I want it to be the opposite, to remove that geometry. Okay, so going into a sketch, if we pick the outside, otherwise I can, this outside face, otherwise when I go into the sketch, I'll get the plane and then I know I'm on center. I wouldn't have to go back and pick. All right, so let's go to the project so that I have that geometry available. And then we're going to go points to points. All right, so if we do the math, that'll end up being the 12.5 and 150. And as soon as I move, it went to the outside, so I need to make sure I'm going to the correct side and then hit the left mouse button to select. So all it really did was change the sign of the 12.5s, and if I had managed to click it on the outside, I would just double click on that dimension and change the size. All right, so here's a couple of constraints that we would work for between these 2 lines. I want to be equal in length from those 2, and then I would also like to be collinear, and we'll go back and pick. All right, so when those projections came in, the main thing with the projection was to have, since that arc curves away, was to have that geometry projected into the current sketch so that I could pick it up and find that point. All right, escape to get out of the orbit, and then we'll go extrude. I'm going to start at the bottom again because I always forget to do the cut. I want to go through all and make sure that it's symmetric. And then finally I will pick, and that wasn't it. So we'll go to the left side, and I'm looking for those 2 regions. And we'll just go back to isometric so that we can see the material that's being removed. All right, so a little bit different than what we did. I'm going to go ahead and save this as Link R2 or ARM or whatever we called it. All right, so at this point, if we want to run the simulation, we have in our modules generative design, the render, animation, simulation. Oh yeah, let's make it a little more interesting too, in that we can open up a sketch, and I would want to try different size hole geometries here. So let's go ahead and put in our diameter, go to the line. X on the keyboard will shift me to a center line, or I can go to construction, and we'll go find points and escape. And what that's going to let me do is find a midpoint. All right, so make sure that's selected, make sure that's selected. There, it jumped. All right, and then we'll need a dimension. I don't want it to interfere too much, so let's go with an 80 millimeter through hole just for lightning. And in our process, maybe we would see what this is like if we made a pocket, if we changed the thickness from 50 to 75. We could see where those geometries come in. So it did the midpoint. It's still in blue, which was a hint. And I thought I got that to go concentric, but since it did not, let's see where I picked. All right, so nope, still didn't go. So where's my center point? Well, if we need to find the original sketch and pick up coincident, that will do it as well. All right, so we're going to finish the sketch, go into the extrude. If I select, it went back to new body. We want to cut that, and this time I will tell it to go through all. But since it's not doing anything, typically that means that it's going the wrong way. So if we reverse the direction, well, that changed it back to a distance. I still want to stay all, so I could have come over here and just clicked on all. All right, so now for the simulation, we'll go ahead and save one more time. And on the manufacturer side, that would create the G&M code for the machine tools, and the drawing would create our documentation. So on the simulation, we're just going to do a static. We have all these other items available. As an education license, you will have enough tokens to run the simulations. And we want, I did not set a material, so let's see if we edit the material, same as the model. It says that it's metal, but that doesn't tell me a lot, so I'm going to go back to the body. There's other ways to get to this, but I like doing it this way because I'm sure that I'm applying, I can see it highlighted, and when I'm applying the metal, I'm reasonably sure that I'm putting it where it belongs. All right, so aluminum, copper, brass, we could run the simulation under different materials. Stainless steel, and I'm just looking for a standard 1020 or 1018. So a little bit, the hot rolled would be fine. So dragging and dropping it, and then we close and back into the simulation, and now the study material should show up as our AISI 1020. All right, so the constraints, we have a structural constraint. and I'm going to restrain it in all directions and hit OK. And these are all just very generic constraints and loads. If we do force, pressure, moments, um, got quite a few selections. We're going to go inside for both of those. And the directions should be okay. So where is my orbit? So I can see the blue arrow is facing up, which would be more in the way of compression. So let's shift that to 180 so that it's pointed down, direction of gravity. And then in newtons, we're going to go with a factor of safety. Let's go 60,000 newtons because I want to see some decent deformation and possibly failure, where the failure analysis will come in and why we would need to beef this up. All right, so we go through the process, and we want to do the pre-check. Has all the required information, and we're ready to solve. So the solve required. I must be signed into my personal account then. Okay, updated my account information, and we're going to go to the solve, and this usually takes a few minutes, so we'll solve one study. So first it meshes, figures out all of the node points, and then it starts in on this process. So I'll go ahead and pause and let this run, and we'll come back and see the result. Okay, so it finished the took a little over a minute to go through the simulation, and the deformation scale is adjusted, so it's pretty usually quite exaggerated, and it's showing us the minimum factor of safety at 4. So I could actually lighten it up a little bit, maybe. We have the stresses on the internal points, so that's not surprising, but we're also not taking into account the pin and the compression on the intersecting links. So let's go ahead and close those. We'll look at the stresses. All right, so stresses in the internal geometry, pretty much concentrated on those points. Our displacement, well, that moved up quite a bit, 0.05. So what about 2 thousandths? Oh yeah, half. So that still is pretty good movement. And then the reaction force is concentrated at the face, the strains carried throughout, and then in the contact, pretty much just straight through. So gives us, kind of the first pass is looking at the gross errors. The mesh is pretty wide open for computing time. A open mesh will process a lot faster. And then as we refine and wanted to go through, notice stress risers, geometry that is problematic, then we could refine it a little bit more, make another pass, and get some more information out of it. So I'll go back to the design first, and when we go into the to the 3-view drawing, then we have the front view, and we're going to go drawing from design, and we'll just go ahead and I prefer to do the manual. We need 2 views and an isometric for this. If we had a full 3 view, the automatic, and we're not doing bodies or an assembly, but we can let it go through. Otherwise, we would pick individual components. All right, so we can place the first item. It's in the front view. Let's see what that looks like at 1 to 4 still. How about half? Not too bad. We'll leave it there for now. And I'm going to project the view for the side. And we'll go for an isometric and then accept it. All right, so that one's pretty good size. So it's picking 1 to 2 from the parent. So let's go maybe 1/8. That looks a little too much. We'll go back to a 1/5 on that one and close it. All right, so I probably would scale this down a little bit more so that the dimensions in the title block are not doing anything too strange. For the dimensions, kind of like in the sketch, we're just going to start applying our geometry. Radius 0.75, we can go between the center points. And it's saying it is not an object, so it pulled the 75. I also could have hit undo. So let's go with the center mark then, and we'll go ahead and apply those. They're a little bit easier to dimension to for the centers. And that one got off a little bit, so let's place that again. There we go, got the center, 125. And then zoom up, make sure I'm picking what I think I'm picking. And we'll go the 250. 80. So kind of the first pass is just to get the dimensions in place. When I want to move a dimension, we need to pick on the grip. And I'll move out a little bit with the scroll wheel. And then place these a little bit better. All right. So then on our other dimensions, let's go from point to point. And we'll see if there's any difference in those selections other than the extension line, having the gap in the proper place. Those look pretty much the same. From our depth then, if we wanted to go from center, probably come back over here and pick the points. All right, so nope, still got the outside of the center mark. And typically we won't dimension to a hidden line, so that would fall into the not so good practice. Line those up a little bit, and then we need an overall. Okay, so just some basic dimension geometry. F6 to fit it to the sheet, and then we would save this, and now we have a working document we print to. If I created my own template, I prefer to go across the bottom, clean that up. Not exactly sure what size I picked either, so this looks like it's a pretty good size sheet anyway. So we'll go ahead and save that and make it into a document drawing that we can come back to and clean up a little bit more later. All right, so that runs through the basics of the mechanical and a couple of the different modules that we can work with.